EMC Antenna Mast. Capstone Team 5. The requirements for this project are to produce an automated antenna mast that is compatible with 4 different types of electromagnetic compatibility antennas housed at the E3 Compliance Test Lab. The mast supports manual adjustment of both the height and boresight angle, and automates the rotation of an EMC antenna with respect to the ground plane from outside the EMC chamber. An EMC antenna is a specialized type of antenna used to measure electromagnetic fields and radiation from electronic devices or systems. The design contains very little metal so as not to introduce or reflect significant electromagnetic noise off the device under test, which may interfere with the test measurements. It is used for testing the electromagnetic compatibility of electronic devices, which refers to the ability of the device to operate without causing interference to other devices or being interfered with by other devices. The antenna mast is a combination of a base, stand, and arm, which holds the antenna in the position desired by the EMC test technician. There are 3 main functions of the antenna mast: height adjustment, boresight angle adjustment, and arm polarization adjustment. The height of the antenna is adjusted by pulling a pin from small holes on the stand. The pin should be placed into the corresponding pinhole to hold the arm in place once a desired height is reached. The vertical and horizontal polarization positions of the antenna are able to be orientated by using a piston and cylinder assembly attached to a cam, which is attached to the mast arm. Once engaged, the pneumatic system pushes the piston up or down on the camshaft, which will move either closer or further from the axis of rotation to move the arm between horizontal and vertical polarizations. The boresight angle is adjusted by pulling a pin from slots which vary between +5 and -40 degrees. The pin should be placed into the respective pinhole to hold the arm in place once a desired angle is reached. In-house software, a low-current microcontroller and fiber optic cable are used to power the pneumatics controller. The MCU receives input from the test technician regarding whether the arm should be in the vertical or horizontal polarization, and this electronic signal with that information is converted to a light signal with the transmitter PCB. The signal then travels through a fiber optic cable to the receiver PCB inside the chamber, which actuates a pneumatic device that pushes air into the double-acting hydraulic cylinder from either the top or bottom, causing the arm to move either vertically or horizontally.